Bridget. The title of my project is The Effect of Gut Microbiota on Parkinson's Disease in Drosophila. The purpose of my research was to answer the question, does removing gut microbiota from Drosophila with a Parkinson's disease mutation eliminate the symptoms of Parkinson's disease? In order to answer this question, I did research on a similar study. This study took a population of mice that expressed the symptoms of Parkinson's disease. It removed gut microbiota from half of these mice, and then tested these mice for their physical capabilities. The group that had their gut microbiota removed expressed the symptoms of Parkinson's disease less than the other group. Therefore, I hypothesized that if I removed gut microbiota from Drosophila that expressed the LRRK gene, equivalent to the LRRK2 gene, a key influencer in Parkinson's disease, then these Drosophila will express the symptoms of Parkinson's disease less than the ones that still have their gut microbiota. In order to conduct my research, I tested 4 groups of 15 flies. The first group was a Parkinson's disease mutant fly with gut microbiota, and the second group was a Parkinson's disease mutant fly without gut microbiota. In order to remove the gut microbiota from these flies, I soaked their eggs in a very diluted bleach solution and fed the adult flies streptomycin powder. Additionally, there were 2 control wild-type fly groups, half of these with and half of these without gut microbiota. At full adulthood, each fly was given 10 seconds to climb up a plastic straw, and the distance that they traveled was recorded. All flies moved up due to a fly's natural tendency to move against gravity. Low climbing ability indicates the symptoms of Parkinson's disease. After all the flies were tested, the average distance traveled by each group was found. The averages for the control groups were 7.8 and 7.85 centimeters. These close numbers prove to me that the process of removing gut microbiota from flies did not harm their physical capabilities, and the rest of my data could be trusted. The Parkinson's disease flies that had their gut microbiota removed followed closely behind the control flies, with 7.66 centimeters traveled. This was 3.21 centimeters farther than the group that still had its gut microbiota, only traveling 4.45 centimeters. Upon viewing this chart, it is very evident that my hypothesis is proven correct. Removing gut microbiota from Parkinson's disease flies does in fact reduce the symptoms that those flies experience. After more research, a valid explanation as to why gut microbiota has such a huge impact on Parkinson's disease could be that gut microbiota produces short-chain fatty acids when it breaks down dietary fiber. Research has shown that these play a part in immune responses in the brain. Therefore, short-chain fatty acids resulting from gut microbiota could be playing a part in brain inflammation and other symptoms of Parkinson's disease. If removing gut microbiota from human Parkinson's patients can almost eliminate the symptoms that those patients experience, just like it did in the Drosophila, the real-world implications of this project could be huge, because it could help to better the lives of more than 10 million people worldwide currently living with Parkinson's disease. A possible extension to this research would be to see if any other diseases or viruses are impacted by gut microbiota. In fact, a small study in Hong Kong has found that higher levels of gut microbiota may put a person at risk for higher severities of COVID-19 symptoms. With COVID-19 being so detrimental all across the world, research on this virus is critical. You can see my research up close and personal and in more detail on my slideshow presentation. Thank you so much for your time.